Hello everyone, Geometry Unit 2, Lesson 1, Logical Reasoning. Today we're going to be using reasoning to make a conjecture or find the next term in a number or picture pattern. Let's get started. Okay, conjecture here in Lesson 1, an educated guess or conclusion based on given evidence. That's what a conjecture is. So example A, consider the diagrams below. Each one shows an example of vertical angles ACB and DCE. Use the diagrams to complete the conjecture. So you can see angles ACB and DCE are the red and blue angles in each of the diagrams. Those are being defined as vertical angles. Thus, the red angles are 100, 120, and 45. And the blue angles are 100, 120, and 45. So a conjecture, I'm going to make a conjecture below, are that vertical angles are congruent. You could say that those are equal in measure. Based on what I can see, I'm making an educated guess or conclusion based on that evidence. All right, let's continue. Okay, let's look at another example. What we're going to do here is take a sequence that's given that has terms. Let's say in our first term, when n equals 1, n is just a notation for the term number. So n equals 1 would be 2, n equals 2, our second term would be 4, n equals 3, our third term would be 7, n equals 4, our fourth term would be 11. So our fifth term, based on the pattern that I'm seeing, I see that we are increasing from term 1 to term 2 by 2, and then term 2 to term 3 by 3, term 3 to term 4 by 4. Therefore, our fifth term would be 5 more than 11. So our fifth term should be 16. Our sixth term, following the same pattern, we're then going to add 6, which would be 22. And our seventh term, we would add 7 to give us 29. Okay, so let's move on to another example and do something very similar. All right, here is a visual pattern or sequence of shapes. So it looks like each of my odd terms are circles. All right, so I've got my first, third, and fifth term. Each of my even terms are polygons. Okay, so I can tell you for sure that my seventh term, it's asking me to come up with the next two shapes, but my seventh term I know will be a circle. Now within the circles, you'll notice that the first term, the upper half is shaded. The second, or the third term, the left half is shaded. The fifth term, the bottom half is shaded. So the seventh term, I'm anticipating for the right half to be shaded. So that should be my seventh term. Let's kind of put that in the sequence above. So that's n equals 7. Now let's look at the eighth term. Now I know the eighth term is going to be a polygon. Here I see in term 2, I see a triangle. Then I see a pentagon. So I went from 3 sides to 5 sides. Then in my sixth term, I went to, it looks like 1, 2, 3, 4, 5, 6, 7 sides. That's a heptagon. So in my ninth term, eighth term, I will have 9 sides. So I should have a nonagon. Now there is also some sequence work going on within the shape itself. You can see that I got open circle, closed circle, open circle, closed circle, open circle, closed circle. So I'm expecting a nonagon. Let's see if I can draw one. That's 4, 5, 6, 7, 8. Hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is a nonagon. It's the best I can do. So deal with it with, it looks like closed circle at the very top vertex and an open circle at each of the bottom 2 vertices that are closest to each other. Okay, so that would be my 7th and 8th terms of that sequence. All right, let's continue with another example. Okay, looking at example C and D and E, would you please go ahead and attempt to find the next 3 terms? Okay, pattern recognition with the next 3 terms. Oh my goodness. Would be if you, there is no algebraic pattern with regards to the fractions itself, but with the numerators I see I get 1, then 2, then 3, that would make 4, and 5, and 6. In the denominators I get 2, 3, 4, so this would be 5, 6, 7. Example D, find the next 3 terms of the pattern. Well, I notice a pattern that I'm multiplying by 3 to get from any term to the next. So the next 3 terms in this pattern would be 27 times 3, which is 81. 81 times 3, which is 243. And 243 times 3, which is, 729. There's the next 3 terms in that pattern. Let's look at example E. Complete the pattern below. Okay, it looks like our pattern is decreasing. So to go from term 1 to term 2, I subtract 1. Then I subtract 2. Then I subtract 3, then I subtract 4, so then I should subtract 5, that would be 5, then I should subtract 6, which would be -1, and look at the pattern matches up. If I subtract 7 from -1, I get -8. Pattern recognition, guys, let's continue on the next slide. Okay, pause the video, attempt to draw the next shape in the pattern. Okay, you're back from drawing the next shape in the pattern. Now let's look at the number of sides. 3 sides. How many diagonals would there be in the first shape? Well, in the first shape, there'd be 0. In the second shape, I've got 5 sides. How many diagonals are there here? Well, you can see that I've got 1 and 2, so I've got 2 diagonals. In the third shape, I've got 1, 2, 3, 4, 5, 6, 7 sides, and 1, 2, 3, 4 diagonals. Okay, so in the next shape, let's see what it would be. I'm anticipating that I'm going to go from 3 sides to 5 sides to 7 sides to 9 sides. Let me see if I can sketch that nonagon again. 4, 5, 6, 7, 8. Bad choice. Oh boy, it was my best. My best nonagon. Well, not as good as the one in the last slide, so apologies, although I'm not really apologizing. So 9 sides. I'm anticipating 0, 2, 4. I'm guessing 6. So let's connect non-consecutive vertices. 3, 4, 5, and 6. It looks like there I would have a nonagon drawing the 6 diagonals of that shape. Now a diagonal is a segment, and now I'm choosing only diagonals from the upper vertex, right? From that very top vertex. Diagonals are segments that connect non-consecutive vertices. Therefore, each of these, right, would not be diagonals because they are on the edge of the shape. Right? So the red segments are diagonals, the blues are side lengths. Okay, so there you go. I've got the next shape in that pattern. Let's look at the next slide. All right, this is kind of a fun slide. You won't be tested on this stuff, but wanted to see if you could figure this out. Each of these letters in the first 2 examples represent stuff that you'd see in the real world. Okay, so in number 1 and number 2. A hint I will give you for number 1 is that there are an infinite number of terms in the sequence. And in number 2, there are a finite number of terms. So there are an uncountable number of terms in the first and an countable number of terms in the second. If you pause the video and attempt it, you can come back and see the answers. So for number 1, now that you've paused the video, the next 3 terms would be SEN. See if that helps. Pause the video again. And there are the next 4 terms. If you're catching on to my pattern here, please let me know in class and we can talk through this. But it's pretty cool. So anyways, in the second example, the next 2 terms, actually we'll go 3 terms, are there. And that leaves for us 5 more terms. So I will give you the hint that there are 12 total. And the last one, this is kind of goofy, but all I've done is take each of the numbers, flip them backwards on themselves, and turn shapes out of them. So the next one would be a 5 backwards followed by a 5 forward. And then a 6 backwards followed by a 6 forward. And a 7 backward followed by a 7 forward, etc. So that would have an infinite number of terms. Okay, guys. Had a little fun in this lesson. Pattern recognition is the name of the game. We will see you in the next video.